Hello, everyone. Before we start today's lesson, let's think about a question. During the measurement process, how can we efficiently collect and record key information and integrate it into the measurement report? Do you often find that manual input is both tedious and prone to errors? Today, we will learn about a powerful tool, the form window in PCDMIS software, which will help us quickly input information and generate reports automatically. Next, we will explore two key topics: introduction to the form window and creation of the form window. By the end of this lesson, you should be proficient in creating form windows in PCDMIS software. Understand the relationship between form window variables and measurement program variables, ensuring that the information in the form window is accurately transferred to the measurement report. Now, let's start by learning about the form window. In PCDMIS software, the form window is used to create interactive tables and dialogues that are embedded into the measurement program. When the program runs, the form window is activated for information transfer and interaction. This enhances the functionality and flexibility of the measurement program. For example, as shown in the image, when the program runs, the operator can intuitively and conveniently input or select certain information. Some of this information, such as the workpiece name, can be transferred to the report, while the coordinate system selection can be used with process control commands to guide the execution of the measurement program. To fully utilize the form window, we first need to create a form file. Next, let's learn how to create a form file. In the software, navigate to File, Report, New, Form Report to enter the form editor and start creating a new form. The form editor contains several toolbars, with the editing page in the center. At the top of the editing page, there are 4 sections: Font bar, Layout bar, Object bar, and Properties bar. Now, let's go over some commonly used tools from the Object bar. The first one is Text, used to insert text labels or annotations. Boundary inserts a rectangular boundary or frame. Structure allows inserting a frame into the form. Typically, when designing functionality in a form, we use structure to group a set of similar function buttons. Image allows inserting pre-created graphics. Radio button inserts single choice options, where only one can be selected. Combo box, also known as a composite list, is displayed in the form of a drop-down menu. Edit box allows users to input specific information into the form. Next, we will use the initially displayed form as an example to explain step by step how to use the tools in the object bar and modify their properties. Boundary, select the boundary function from the object bar. Use the left mouse button to drag within the editing page to create a rectangular selection frame. Right-click to open the boundary properties editing page. We usually modify the borderline thickness. For example, if we change the current line width from 1 to 2 and press Enter, the modification is complete. Image, select the image function. Similarly, use the right mouse button to drag an area within the editing page. After releasing the mouse, a bitmap dialog box will appear. Click the Load button, select the image we want to add. Note, the form supports bitmap, BMP, and JPG image formats. And then click OK. Now, the image will be displayed in the form editing page. Text. We usually use the text function to annotate or describe certain information. Select the text function. Use the left mouse button to drag within the editing page, and enter the desired text in the appearing text box. Here, enter part name. And increase the font size to 22. On the right side, insert an edit box by selecting the edit box function, which allows data input. Typically, data or values entered in the edit box will be used as variables in the measurement program. Therefore, for tools that transmit variables, we need to modify the object name. This name will be used to link the edit box input with the measurement program variables. For example, in this edit box, the part name will be entered. Thus, in the Properties panel, modify its object name to PN, which stands for part name. Copy a text box and enter inspector. Then, insert a combo box drop-down list on the right side. Similarly, modify the object name of the combo box to OP. Next, select List Item Collection, and in the pop-up dialog box, use the Add button to enter the names of 3 inspectors, Zhang San, Li Si and Wang Wu. Define their values as 1, 2, and 3 respectively. Zhang San value 1. Click Add. Li Si value 2. Click Add. Wang Wu value 3. Click OK. Lastly, structure. Select the structure function. Use the left mouse button to drag within the editing page to create a structural box. Modify the text in the top left corner of the structure box to coordinate system, and increase the font size to 22. Change the background color to gray to differentiate it. Radio button. Select the radio button function and insert it into the form. The selected radio button value is also a required variable in the measurement data. Thus, in the Properties panel, modify the object name of the radio button to ALI. Radio buttons are used to select only one option from multiple choices. For the coordinate system selection, we add 2 options. The first one is MAN plus DCC, Manual plus Automatic Coordinate System. MAN plus DCC. Set value to 0. The second is DCC, Automatic Coordinate System. Set value to 1. Now, the form is successfully created. Use File, Save, to set the save location and name of the form file. The file extension for form files is .flm. A form file is independent of the PCDMIS measurement program. It is a separate file. Therefore, if we want the form to be activated during program execution, we need to insert it into the measurement program. In the software, select Insert. Report command. Table. Choose the prepared form file and click Confirm. At this point, the measurement program will display the form file path and name. However, simply inserting the form into the measurement program does not complete its functionality. The final step is to convert the inputs or selections from the form into variables and then pass them to the measurement program. For example, in this lesson's form instance, the form collects the following information: the inputted part name, the selected inspector from the drop-down list, and the coordinate system execution method. To handle these 3 pieces of information, we first define 3 variables using the assignment function, corresponding to each item. Part name. Assigned from the inputted part name, enclosed in double quotes. Operator. Assigned from the selected inspector, enclosed in double quotes. And Manali. set to 0, used to store the coordinate system selection result. Next, we need to link the form variables from the edit box, combo box, and radio button to these three defined variables. The corresponding format must be followed. The input content for the part name is formatted as pn.text. For the inspector, it is op.text, where pn and op are the object names we defined for the edit box and combo box. The radio button uses the suffix .value, which allows for custom-defined values in the list. Here, it corresponds to ali.value. Now, we set the parameters as follows: pn.text equals part name. During actual execution, part name will be replaced by the content entered in the edit box. op.text equals operator. Operator will be replaced by the selected inspector in the combo box. ali.value equals Manali. ali.value will be replaced by the value corresponding to the selected radio button option. Press Ctrl+U to run a test. Now, we can input the part name, select the inspector, and choose the coordinate system execution method. This concludes the form creation process. In today's lesson, we thoroughly studied the creation and application of forms in PCDMIS software. Through hands-on exercises, we not only mastered the features and techniques of the form editor, but also learned how to successfully integrate the form into the measurement program, enabling data transmission and interaction. This skill is crucial for improving measurement efficiency and simplifying the report generation process. I encourage everyone to review today's lesson carefully and apply what you've learned in practice. This concludes today's lesson. Thank you, everyone.